Okay, we're back. This is Clinton Weir. We're talking about my final project for University of Illinois Springfield CSC 535 Deep Learning. I have been trying to figure out why this import statement, import tensorflow.keras.utils, is here. I'm not sure. It must be that in the course of working on the project, at some point I must have been, I've had various difficulties with this project, and of course in the course of attempting to work my way around some kind of a problem, this must have been part of some technique that I was using. I don't see where I am using it at this time, so that's got to be an artifact. Okay, so import from random, import seed. That's obvious. You do that to get. I don't think I use this very much either. I certainly don't use it to the extent that I should to get repeatable results from processes that are to one degree or another random. Obviously I had planned to do that, and I can tell you I just it didn't work out very well. I didn't build this into my code as well as I should have. Alright, moving on. We have this piece of code here, get early stopping. This is to get a instance. This is not really strictly necessary. I chose to use it to ensure consistency. I landed on a default patience of 25. So the main reason why this is here, before I had just something like early stopping equals blah blah blah. And what I figured out, in this, is something I should have realized quicker. But if you do this, if you do early stopping equals blah blah blah, you're gonna get you're gonna get an instance of an object, and this object is gonna keep track of whatever metric that you tell it to naturally. Well, something I did not immediately realize is that it doesn't really keep track of what model it is tracking. It is not something that, it's not a piece of code that tells the model, okay, remember you got to keep track. No, it doesn't do that. What it does, apparently, is this is a piece of memory. This is a object that it's a piece of memory that keeps track, that it has information about the metric that it's tracking. That's it. And when the metric fails to improve after so many epochs, it tells the model to stop I'm not sure this is strictly the way I should say this, but it tells the model to stop training. So the model is in a training process. It's telling the early stopping instance callback. It's saying, hey, this is the metric for this epoch, and the early stopping object says, okay, I wrote that down. Keep going, and then the early stopping object compares that to the best number it has. Well, let me say it a different way. The training object, the model, tells the early stopping object, hey, here's the metric for my last epoch. The early stopping object writes it down. It looks back. When was the last time, is this the best? Is it better than the last best? If it's the best, great. If it's not the best, then it looks back. How many epochs ago was the last best? If it's within 25, great. Either way, whether it's the best or if the best epoch was less than 25 epochs ago, then it tells the model, keep on going. If the most recent epoch did not achieve the best metric value, and the best metric value was was at least 25. I don't know if it's more than or if it's at least, but either way, if the epoch with the best metric value was too long ago, then the callback, the early stopping, will tell the model to stop training. But the key point is the early stopping object doesn't care what model was being trained 25 epochs ago. So, you have a model, you're training it, you get done, you bring over the same early stopping object, you keep it around, you build a new model, you start training it, you pass that same early stopping object to it. Well, the early stopping object, it doesn't realize, it doesn't know that you've started a new training series. So it keeps looking back at the numbers from the other model. And long story short, this has the tendency of making the new model halt training prematurely. And that's what I had to figure out, because that's what my inclination, because I wanted to use the same the same parameters for the early stopping object. I wanted to use the same parameters from one model to the next. So I was doing this thing, early stopping equals whatever, and I was just reusing that object for each of my model training, each time. And so I was getting wonky results. I was thinking, why is my model only training for however many epochs? And it took me sadly, it took me a while to figure out why it was. So this is a way to get around that. I still want to use an early stopping callback object. Still want to use one with the same parameters, but I need to instantiate the callback object each time I want to train a new model. This is how I accomplish that. I have a method that instantiates the object and returns it. Bingo. All right. So the next code, we'll go ahead and stop here, and then we'll talk about this block next. Although I've already talked at length about the tricky part. Anyway.